All right, example 1. The combustion of methane gas is an exothermic reaction. When 1 mole of methane burns, this much energy in kilojoules is released. So we have 3 ways where we can express this relationship. The first way is to write the molar enthalpy change beside the chemical equation. So we have methane. It's undergoing combustion. If it doesn't tell you, assume complete combustion. You should know this from grade 11. When we're balancing combustion, start with carbon. Carbon's already balanced here. Hydrogen's is next. Now we have 4 oxygens on this side, and we want 4 on that side. So since we know that this is an exothermic reaction and energy is being released, when I write the molar enthalpy beside my equation, I know I'm going to write a negative in front of this value. Exothermic is always negative, and endothermic is always positive. I know that this is in terms of 1 mole of methane, so I don't have to write per mole to the side. Okay. For a thermochemical equation, we're going to put this directly in my chemical equation. So we have methane, oxygen gas, carbon dioxide, and water vapor. Because this is exothermic, I know that energy is being released and it's a product. So I'm going to add it right in here. I can't have a negative in a chemical equation, so I put plus this much energy because it's a product. If it was endothermic, it would be added as a reactant. Exothermic product. All right, let's draw a potential energy diagram. Here we have potential energy, and this is in kilojoules. On the bottom, we have reaction progress. Okay, because this is exothermic, my reactants have a lot more potential energy than my products. You have to write your reactants right on here. My arrow is going to point down. That is my change in enthalpy. And I'm going to label over here, delta H is equal to negative 802.8 kilojoules per mole. And then I'm going to write my reactants, CO2 gas plus 2H2O gas. Okay, so this is for an exothermic reaction. If we had an endothermic reaction, it would look a little bit different. I would still have the same labels, so potential energy in kilojoules, and I would have reaction progress. But in endothermic, my reactants have less potential energy than my products, so my graph looks a little bit different. So if I have A plus B making C, the energy that I could knock off is maybe positive 825.1 kilojoules per mole. Okay, so just an example that I made up. You should know the difference between these two here. So that is expressing molar enthalpy in 3 different ways.